Good morning, class. Recall that last week we discussed about balancing chemical equations, and then we were also able to discuss about the different types of reactions. So at this point, we are ready to discuss about stoichiometry, which is just the relationship between the amounts of reactants and products. So there are two phases. So we will have stoichiometry, which involve calculations involving chemical formulas, also calculations involving balance equations. So today we shall discuss the first part, which are calculations involving chemical formulas. So first is the concept of molecular weight, which we shall denote by MW, which is just the sum of masses of the atoms present in 1 mole of a substance, which can be an element or a compound. Now, the molecular weight is expressed in terms of gram per mole or kilogram per mole. For example, we are asked to find the molecular weight of sulfuric acid. So it is very imperative that we know how to write chemical formula. So for us to be able to determine the molecular weight. So recall our knowledge of writing formula. So sulfuric acid. So from the sulfate ion, SO4, which is the sulfate ion. So we convert that into acid. So we affix H2. So the formula for sulfuric acid is H2SO4. Okay, so how did we define molecular weight? So it's just the sum of the mass of each element present in the formula. So in the formula, we have 2 atoms of hydrogen, we have 1 atom of sulfur, and then 4 atoms of oxygen. So we just have to multiply each element with its corresponding atomic weight, which is a data from the periodic table. So hydrogen has an atomic weight of 1.01 gram. So you just multiply that by 2. So you have the corresponding value of 2.02. Sulfur is 32.06. So there is 1 atom of sulfur. So we have 32.06. And oxygen in sulfuric acid. Sulfuric acid has 4 oxygen, so we multiply 16, which is the atomic weight of oxygen, by 4, so to have 64, and then we just simply add all. So remember, it's the sum of the masses of each individual atom. So the molecular weight of sulfuric acid is 98.0 grams. So per mole, so 1 mole of sulfuric acid is 98.08 grams. Another example is if you're asked to find the molecular weight of calcium sulfate pentahydrate. Again, we write the formula. So that is CaSO4 for calcium sulfate. And then penta meaning 5. Then hydrate, so 5 moles of water. So what are the elements involved in the formula? So we have 4 elements. So we have calcium, sulfur, oxygen, and then hydrogen. So you count the number of atoms of each, the number of atoms of each element. So how do you determine that? So you just look at the subscript. So that is the number which is located down in the formula. So for calcium, we have 1 atom of calcium. Sulfur, we have 1 atom of sulfur. We have 4 atoms of oxygen from calcium sulfate, but we have 5 atoms of oxygen from water for pentahydrate. So we have 4 plus 5, so that's 9. 9 atoms of oxygen, and then we have 10 atoms of hydrogen. So 5 times 2, that's 10. And then again, we multiply that by the corresponding atomic weight of each element. So for calcium, we have 40.08. For sulfur, 32.06. Oxygen, 16. So you multiply that by 9. So you have 144. And then for hydrogen, the atomic weight is 1.01. You multiply that with 10. So we have 10.10. And therefore, the molecular weight of calcium sulfate pentahydrate is 226.24 gram per mole. The next concept is the mole, which we have already encountered when we discussed measurement, system of measurement of 7 mole is one of the 7 fundamental quantities. So it is defined as the amount of substance which contains as many elementary entities as there are atoms in exactly 12 grams of carbon. So we can use the concept dozen as an analogy. So 1 dozen anywhere contains 12 pieces of anything. No? So that's analogous to a mole. 1 dozen contains 12 pieces. So 1 mole contains Avogadro's number. So what's Avogadro's number? That's 6.022 times 10 to the 23rd particle. So a particle could be atom, molecule, or ion pairs. And therefore, 1 mole contains that number of particles. So analogously, a dozen contains 12 pieces. For example, a dozen of calamansi contains 12 pieces of calamansi and would weigh a certain weight. And a dozen of, let us say, mangoes would also contain 12 pieces of mangoes, but would weigh differently because mangoes are much bigger than calamansi. So that's also the concept of mole. A mole contains exactly Avogadro's number of particles. So 6.022 times 10 to the 23rd. However, the weight would be different depending on the size of the particle. So we would expect that a mole of an entity which is bigger than compared to another entity will be, the weight will be higher. So for example, 1 mole of sodium contains Avogadro's number of sodium atoms. It's 6.022 times 10 to the 23rd sodium atoms and would weigh 22.99, so almost 23 grams. A mole of sulfur, on the other hand, would weigh 32.07, but it will also contain the same number of sulfur atoms. So suffice to say, if we compare the two outrightly, we would know that sulfur is bigger than sodium because it weighs more. No? A mole of sulfur weighs higher than a mole of sodium. A mole of water would contain the same number of particles. So Avogadro's number 6.022 times 10 to the 23rd. So it should be 23. So we need to correct this. So 6.022 times 10 to the 23rd water molecules, because water is a molecule and weighs 18.02 grams. So relatively, water molecule is much, much smaller than a sulfur atom. Now note that we have this relationship in the number of mole is the ratio between the mass and the molecular weight of a particular substance. The next concept is the percentage composition, which is just the ratio of the total mass of each element to the total mass multiplied by 100%. So recall how we computed for the molecular weight earlier. So we just get the relative mass of each element. So remember, hydrogen is 2.02 grams. So that's 2 atoms of hydrogen. And then the molecular weight of sulfuric acid is 98. So that's the denominator. So in a molecule of sulfuric acid, hydrogen is 2.06%. Sulfur is 32.69%. So just divide 32.06, which is the atomic weight of sulfur, divided by the molecular weight of sulfur. We do the same thing with oxygen. So 62.25. So notice that if you add each percentage, then you should get 100%. Okay, so based on this example, we note outrightly that in sulfuric, oxygen is the most abundant chemical in sulfuric acid. So a sulfuric acid contains 65% oxygen. And then the last concept is the empirical formula and molecular formula. The empirical formula is also called as the simplest formula, because it gives the simplest ratio of the atoms present, whereas the molecular formula is the actual ratio of the atoms present in the molecule of a compound. For example, hydrogen peroxide is H2O2. The empirical formula is HO. 1:1, 1 hydrogen to 1 oxygen. That's the simplest ratio. However, the molecular formula gives you the actual ratio, and therefore, the molecular formula of hydrogen peroxide is H2O2. Note that the empirical formula and the molecular formula can be derived from the given percentage composition of a compound. Now, the basic objective is to find the number of moles of each element, and from the number of moles, you get the mole ratio. The mole ratio is equal to atom ratio. Now, the atom ratio will finally give you the simplest formula, or the empirical formula. Now, if the molar mass is given, then you can proceed to solve for the molecular formula. So that's it. So that's about the first phase of the stoichiometry, which involves calculations which would use chemical formula. So we have mole, we have molecular weight, we have percentage composition, we have empirical formula, and then we have molecular formula. So let us try to use these concepts in problem solving. So let's proceed with problem solving class.